All right, hi everyone. We're gonna get started now. So first, today I'm going to be talking about Typescripts, which you guys might be familiar with if you took 6031 recently, but otherwise you probably haven't heard much about. So yeah, this is a completely optional lecture that you don't have to incorporate into your projects at all. It's just in case you want to learn more about what a lot of the processes a lot of people use when making web apps. So first, some reminders. So we have a hackathon tomorrow evening from 7 p.m. to 1 a.m. And this is your last chance to get live help from the staff before Milestone 2 is due. I think Milestone 2 is due on like Tuesday or something. So oh yeah, that's what the slide says. All right, cool. Yeah, so Milestone 2, the MVP of your website, is due on Tuesday at 6 p.m. And you can find more about the requirements at this link. But basically, you need to have like a site that's deployed on the internet that we can access, and like your main feature should be implemented. And yeah, and just a reminder that all milestones are required to get credit for the class or to compete in the competition. And also, yeah, just make sure to read the pinned Piazza posts. It has a lot of helpful information, like where to find the skeleton code, and then like things like common bugs we've run into that you might need to know how to fix and stuff like that. And tomorrow we have a very important lecture on how to deploy, which is basically like how do you take all your code that's running on your computer and deploy it to like an external website that other people can access. And you have to deploy your website for the MVP. So make sure you come to that lecture and know how to do that. All right, so now let's actually get into TypeScript. So far in this class, all we've been doing is talking about how to code in JavaScript, right? And that's good, but TypeScript is like a language that's built on top of JavaScript with even more features. So specifically, TypeScript is a language with static typing. And what that means is when you write some code, the compiler, like before you actually run the code, the compiler will go through all your code and look at all the variables, and then it'll check like the type of each variable and check if that makes sense or not. So basically, for example, if you have a language without static typing, like Python or normal JavaScript, you can have like variables A and B, and you just multiply A and B, right? If like they're both numbers. But if you have like A is actually a string and B is actually an array, and you try multiplying A and B, like it's not going to work, right? But you might not notice that until you actually run your code. And what static typing does is it will check those variable types beforehand, and it'll say like, oh, you're trying to multiply a string by an array. That makes no sense. So basically what that means is it can help you debug a lot of bugs while you're actually writing code and before you actually have to run it. So why do we care about static typing? Here are some like explicit examples of bugs that I've actually seen or run into myself, and static typing can catch all of these. So one common bug is you're like passing in a prop from one component to another component, right? And maybe like in one component, your prop is like called prop.userID, and the ID is capitalized. And in the other component where you're passing in like user ID lowercase. This is like the wrong prop, right? Or maybe you're like passing in a prop that's user ID, but then your child component never actually uses user ID in any of the code. So in that case, like you might as well just not pass it in, right? Because you're never using it. So TypeScript can catch that. Similarly, if you have a bunch of variables or functions and they're named very similarly and they're like kind of confusing, TypeScript can catch that too. For example, I think in one of the socket lectures, when we were doing the workshop, one of the staff members like accidentally wrote like get socket from socket ID instead of like get socket from person ID or something. And this kind of issue is like really easy to make when you have a lot of functions, and TypeScript can help catch those as well. Another example of a bug that we can fix is with null value behavior. So basically, a lot of objects in programming languages like JavaScript can be null or like undefined in the case of JavaScript. And when an object is undefined, you have like a special case where you like can't run most methods on the object, right? And if you're curious, you can look up more about null value behavior. Basically, the creator of null values, like 40 years later, was like, yeah, this is a $1 billion mistake I made, because it's literally cost companies billions of dollars in debugging and like developing time. And finally, another issue that static typing can help catch is if you have overloaded operators. So I'll just show an example of what that means. We can just demo it in the JavaScript console, actually. So I'm just going to open a tab, open JavaScript. Can I make this bigger? Right. Yeah. All right. So if I want to type 2 + 2, what should I get? Louder. Yeah, good job. All right. So now let's say I want to do 2 + 2 again, but one of my variables is actually a string. So what do we want this to return? Yeah, we want it to give an error, right? But if you do this in JavaScript, you actually won't get an error, right? You'll just get a string 22. Because what JavaScript will do is this plus operator, it'll turn this 2 number into a string. And similarly, if you do string 2 + 2, you'll get 22. And string 2 + string 2 gives you like 22 again, right? So hopefully you guys can see the issue here, right? Because if you have a bunch of data and like some of it is strings and some of it is numbers, or like maybe you store your data in a database as a string, but you like forget to convert it back to a number, you will never run into an error, right? JavaScript will not throw any errors because this plus operator has been overloaded to handle both numbers and strings. And what that means is your program and your website won't crash, but it'll display like results that are completely nonsense, right? Here's another example that I ran into actually when I was making my own app once. So if I have like if I compare 9 and 10, like this should be false, right? Because 9 is less than 10. But if I have like string 9 compared with string 10, this will be true. And so this is really annoying. Basically, what it means is that if you don't actually know the type of each of your variables, you can have really unexpected behavior and your program won't crash. All right, so that's a problem. And TypeScript can actually help fix this because basically when you have weird behavior, you can just like look at your variables and see what types they are. And then you'll be able to see like, oh, I'm actually adding strings to each other instead of numbers. And all of these kinds of bugs might seem really obvious. Like you can just be like, oh, that's dumb, right? I would never do that in practice. I would just make sure all my variables are numbers. But if you have more and more complex code bases, the chances of just having these kinds of bugs just goes way up. And especially also if you have teammates who like are sleep deprived or something, like these bugs are just really common. All right, so now let's talk about how we actually use TypeScript. So here's the syntax. I have a variable called message, and it's just saying, message just has hello world in it, right? And if I want to tell TypeScript what the type of message is, I just put a colon afterwards, and then I put string. And what that tells TypeScript is that the type of message is a string. And now later on, if I forget that TypeScript, or if I forget that message was supposed to be a string, and then I set message equal to 1 in VS Code, like VS Code will just complain that there's an error here because you're trying to turn a string into a number and you can't do that directly, right? You can do this with other types like booleans and numbers. And yeah, basically use this colon syntax to check to like set the type of a variable. Some more examples of types. So here I have, on the left, I have an array of strings. And the way you denote that is just the type is string and then brackets. The brackets just means array. So if you like had something else before the brackets, like number bracket, it would be an array of numbers. Similarly, let me move this. If I want to define like a color, and this color should only be red, green, or blue. One way I could do that is I could just make sure that color is a string. but that might not be good enough, because if color is a string, then for example, I could write like color equals car, and that would be a string, but it wouldn't actually be a color, right? So instead, if I just have like a few specific values I want my type to be, I can say type color is red or green or blue. And then if I define a variable called color, then VS Code will actually tell me that these are your only 3 options, and it'll just like list them out for you. So it's really easy to just code. So in general, if you have an object with some properties, this is how you define the type. So here I have a user type, and user is an object with 3 fields. It has the ID field, the name field, and the isAdmin field. And you just specify what each of the types is. So the ID and name are both strings, and the admin is a Boolean. And if you have a question mark before the colon, that means it's actually optional. It's an optional parameter. So your objects don't have to include the isAdmin Boolean. And here's an example where we don't actually include it. Yeah, so you can use types with other types as well. And this is similar to the example we had earlier, where after we define a user type, we can create a new type, which is an array of users. And the syntax for that is just user with brackets at the end. And yeah, so that's how you basically extend types with other types. And another way you can do this, or like the actual way you extend types, is if I have like a user with these 3 fields, which are the ID, name, and admin, and then I want to define another type, which has the same 3 fields, but it also has password. One way you could do that is just write out all 4 fields explicitly. But if you're going to just reuse the types from another field, from another type, or the fields from another type, you can just extend that with this AND syntax. And what that means is I'll take all the fields from this user type, and I'll also add in a password field. And yeah, here's an example where we actually create a user login. So now it has a password field as well. So another thing about JavaScript is that it has first-class functions. And what that means is that a function in JavaScript is like a normal variable, right? Like, for example, your function can return a function as its result and stuff like that. And what that means is that functions also have types, right? So here I have a getComments function. And what it'll do is it'll take an ID and return a bunch of comments. So if I want to type that, the way I would do that is I would look at the parameter, which is ID, and I just specify ID : string. And that'll tell TypeScript that the ID has to be a string. And similarly, I also have to type the return value. So that the return value is an array of comments. So I put that after the parameters. So like parameters are ID and then : comment array. And basically, when you're typing a function, all you care about is typing the inputs and then typing the outputs. And then the function will do something in between, and we don't really care what it does. But this is how you get the type signature of a function. And similarly, if you have an anonymous function, you can define it like this. So this is saying it takes no inputs, and then it returns void as an output. And that's another way to type, basically get the type of a function. So we can also do this with built-in events in React. For example, if you guys looked at like the to-do list homework that we sent in homework 3, what it does is it takes an input form, and then like every time the input changes in the form or in the text box, we like have this handle change function, right? And so the type of that event is react.changeEvent HTML input element. And so each of these events always has its own type that React has defined. And if you want to get the type, you can just Google it. Like you're not expected to know what this type is. Also, VS Code might just suggest the type for you if you're using TypeScript. And we can also do this with asynchronous functions. So if you guys remember Nick's lecture from yesterday, asynchronous functions should return a promise, right? And what all that means is that when you specify the type of the return value, you just need to wrap the return value in a promise. So it just looks like that. And yeah, if you had like, if you're returning like a number, it would just be promise brackets with number in the middle. So the great thing about TypeScript is it's really easy to integrate with your projects. And what that means is that if you already have a React project, you don't have to convert all of it to TypeScript. You can just like install TypeScript and then convert parts of your project into TypeScript and leave the rest in JavaScript if you want. So if you really wanted to, you could actually be like this person and all they do is set up TypeScript and then write all their code in JavaScript. Don't do this, but yeah, you could if you wanted to. And also the other good thing about TypeScript with React is you can like define React props and states with, you can define the types of those, and I'll show how to do that next. Right, so here's how we deal with props and states in TypeScript. So I have this profile component and it takes in some props, right? And previously, when we were doing normal React, we were just saying, oh yeah, the props will have like a props.id or a props.username or whatever, and we don't really care what the props actually have inside. But with TypeScript, what you can do is you can say, all right, I want this props to have a specific type called profile props. And I'm going to define what profile props is. Profile props is only going to contain a user ID, and the user ID has to be a string. So now if you have this profile component and the prop has been defined, the prop type has been defined, then when you try to create a parent component in another file, and you say like, I want to pass in these props to profile, the only data that you'll be able to pass in is this user ID string. And that'll save you from bugs, like some of the ones I mentioned earlier. Like if you try to pass in user ID, which is lowercase, TypeScript and VS Code won't let you, because it'll be like, it'll tell you, oh, you're supposed to pass in user ID capitalized, stuff like that. And similarly, if we want to integrate TypeScript with state variables, what we do this, the syntax for that is like this. So we're still going to use the useState hook. And depending on the value, the initial value we pass into useState, we might need to specify the type, or TypeScript can figure it out on its own. So for example, here on the second line, we have const cat happiness, set cat happiness is useState of 0. And when you do this, like basically TypeScript already knows that if you do useState with 0, then like cat happiness is probably going to be a number, right? So in this case, in this case, TypeScript already knows that this type will be a number, and you don't have to define it. But in the other case, like the first line, we pass in useState, but the initial value is just undefined. And if you pass in an initial value which is undefined, TypeScript has no way of knowing what type you actually want user to be, right? So the way you specify that is you put the type in these angle brackets, and you just say, I want this type of user to be user or undefined. And then that way, TypeScript will know that in the future, when you try to change user, you can only change it to another user type. And earlier, we were talking about how you can like write a bunch of code in some JavaScript file, and then like you export those components for use in other files, right? And you can do the same thing with types. So here we just defined a bunch of types, like for user, message, and chat data. And then let me move this. And then you can just export those and import them into other files. So if you have like some user type that you're using over and over again in your code, you just define it in one place, you export it to be used everywhere else. So now let's talk about how we actually set up TypeScript. So if you're starting with an existing project, you can just click on this link that is in the slides, and it'll show you like if you already have a React app, to convert it to TypeScript, you like install the TypeScript packages, and then you add like a configuration file, and then you do stuff, and you just convert your code to TypeScript. And otherwise, if you're starting from scratch, you can just use the TypeScript skeleton we provided for you. So you just go to the skeleton code in GitHub, and you switch to the TypeScript branch, and that'll give you a TypeScript skeleton. And one other thing, which I'll show soon, is for every TypeScript project in React, there's a tsconfig.json file. And what this file does is it specifies your TypeScript settings for the project. So what that means is TypeScript can be very strict or not strict at all, depending on what settings you want. Like it can give you more constraints on your code or less constraints. And this config file just specifies how strict it should be. So I'll show you that in a bit. But basically, yeah, if you want to see an example of catbook where all the code has been converted to TypeScript, check out this TypeScript functional branch, and then you have to run npm install to install the new TypeScript packages. But yeah, and also use the TypeScript skeleton only if you want to. You don't have to. But yeah, so now let's look at some actual, just a bit of code, because we have like a few minutes left before the next lecture. So first, I'm going to show you package.json. And so this is, let me full screen this. No, all right. Wait, how do I make this bigger? Okay, cool. Yeah. So here's our list of packages, and it looks like the normal ones from catbook, except now we've installed TypeScript, and we've installed, I guess we just installed TypeScript and a few other types packages here. And now I'll show you the Tsconfig file. So here you can see the settings we've actually used for this TypeScript project. What we're saying is, for example, if you look at this allow.js field, we're saying it's true. And what that means is this TypeScript project can still use normal JavaScript if we want to. If you set this to false, then all your code will have to be in TypeScript. So you would have to convert all these files. So that's a lot of work, but it also allows you to have more consistency in your code. So it's up to you to decide which one to use. And similarly for some of these other types or settings are all about how strict you want your TypeScript to be. So now let's look at some actual code. Here's chatbook, and all I've done is I converted it to TypeScript. So what that means is first we define some types that we want to use for each of the objects. And now if you look at the actual chatbook component, it looks very similar to what it was in workshop 9, right? Like basically the only difference is like the stuff you see in green. So if we look at like this file, like almost all of it is the same, right? Like we're returning the same stuff. And if you look at like this socket code looks like identical to what it was from workshop 9. But the only difference is that we specified some types. So we said that props should always be chatbook props, which means it should have a user ID, which is a string. And similarly for the state variables, we specified that the active user should be a list of users. And we specified that the active chat should be a chat data type. And now, for example, what that means is that if I just hover over like a random like data or variable in this file, VS Code will tell me that like active chat's type is chat data, right? Or for example, if I take like this data, wait, no, what's a good example? All right, let's say we're like trying to do something with our props, right? And I say I want to use like props.username. Like, wait. Yeah, so this will throw an error, right? Like VS Code will just underline this immediately and tell me, hey, you never defined props with a username field and stuff like that. So yeah, basically, if you want to use TypeScript, you can, and it'll help you debug, but you don't have to because it also is a little more annoying to write code for. And yeah, I think that's all I had for this lecture. I think next we have gather, right? All right. Yeah, that's all. Thanks, guys.